So in the next example, in this one, we're going to see two triangle, connecting triangle, very much like what you have done in Pythagoras theorem. So it's just that Pythagoras theorem focus on finding length. So in the two connected triangle. So in two connected triangle, we can be finding length, we can be finding angles. But right now we're also focusing on length. So again, when you've got two triangle, look at the connecting one. So the connecting one is the one that the values is transferable between the triangle. So we are still going to repeat the same steps. Okay, so we're going to repeat the same steps. Okay, but it will be a bit more complex right now. Okay, so they gave us all the information. You're ultimately trying to find CD. And if you look, CD is the hypotenuse here. And in this triangle, you don't have any other length at all. So we got to rely on the connecting length. So I'm going to rely on the connecting length. That means I'm going to rely on the red triangle first. So in the red triangle, this is my angle. So this is my opposite. This is my adjacent. The 90-degree will tell me the hypotenuse. So in the red triangle, which length am I interested in? I can be interested in the opposite. I can be interested in the adjacent. Okay, adjacent no need. Adjacent is already 15. Or I can be interested in the hypotenuse. Okay, so some people may be thinking, I want to get the hypotenuse so that I can do a Pythagoras to get O. Well, you could have gotten your O directly. You could have gotten your O directly. So why do I say so? So you can cross out this. So you can make use of your O and A. So O and A will be the TOA. So I should be using this formula. My angle is 38. My O is AC. So if a triangle has clearly indicated labeling, they indicate the ABC already. So you relate the opposite length in this way. So that's AC. AC and my adjacent is 15. So I got AC over 15. Okay, do the same thing. Set up for your cross multiplication. So if you look carefully, right, your AC is not your final answer. So it's not your final answer. So you can choose to leave it like 15 times tangent 38, or you can punch it out. But if you're going to punch it out, right, you got to remember it's not a nice number and this is not your final answer. So you got to be writing a lot of decimal because it's not your final answer. Because you're going to continue using that AC on the next triangle to find CD. So if you look carefully, AC has become the adjacent. AC has become the adjacent in this triangle. And you are interested to find H. So A and H, it will be the cosine formula. So the angle is 32. The adjacent is the AC that you found just now. So for the AC that you have found just now, Okay, if you want to, you can be using the long chain of decimal. The H is the notation CD. So you do it this way. It looks a little bit confusing, so you gotta get used to it. Okay, and you got another ugly decimal here. Remember, cosine 32 is also quite ugly. So if you want to, you can also press out cosine 32. It's just that you got to be writing a lot of decimal. So just be a bit patient with it. Then you go for your cross multiplication. And then you will divide over to find your CD. So again, you are going to get a lot of decimal. So give your final answer as 3SF. Only final answer will have 3SF. In between, right, you just have to deal with a lot of decimal. So it will look a lot more tedious than Pythagoras theorem to find length. But you cannot always be doing Pythagoras theorem because sometimes you don't have sufficient length. You might have angles instead of length. So when you got angles, then you've got to relate it to the trigo ratio.